When we speak about rigid bodies, we speak about objects that are affected by collisions and accelerations. When you add a rigid body to a game object, make sure there is also a collider attached to it, since that's what the rigid body uses to detect collisions. I'll show you with a quick demonstration. If we grab the box collider of this cube and make it bigger on its feet, you'll see that the cube stops moving when the collision box interacts with those of other objects. We know that rigid bodies are affected by external forces. This means we don't have much control on how they move. That's where kinematic rigid bodies come in hand. They allow you to manually move the transform of the game object while still being able to interact with other rigid bodies. Keep in mind that kinematic rigid bodies don't move or rotate if others collide with it. Collision detection isn't consistent. Collisions are checked for on each fixed update tick, which means that if they move fast enough, they can go through objects. Here, I'll show you. From a low height, the cube lands correctly on the surface below it. But now, let's grab this cube and make it fall from 50 units of height. You'll see how it goes straight through the ground. By setting the collision detection mode to continuous, we tell the game engine to check for collisions at every tick of update instead. This means that the rigid body's collisions are checked for much more frequently, stopping the cube from falling to the ground. This option can lower your game's performance, so use it only if necessary. To modify the speed of gravity, we have to reach for the project settings menu and enter the physics tab. Increasing or decreasing gravity is needed if you're making a 2D platformer or a game that's in space, where you have less gravity. Gravity influences all rigid bodies. It's also possible to modify gravity on X, Y, and Z axes. Another tool we have to control rigid bodies is the use of rigid body constraints. Constraints are useful because they allow us to block a rigid body's movement in specific directions and rotations. Here, I blocked movement on the X, Y, and Z axis. Note that gravity is still enabled and the cube is not falling. If I disable the constraint on the Y axis, the cube falls. Rotation constraints behave just like position constraints, but they don't allow the object to rotate in set directions. Rigid bodies, like all other components, are controllable by script. Here we create an example script and attach it to our game object. First things first, let's grab a reference to the component and assign it to start. As you can see, there are many different methods that belong to the rigid body class. In these, we can find add force. Think of it as a push in a certain direction. Add torque as rotational force in the direction given. Move position and move rotation are self-explanatory, but are to be used only when your rigid body is kinematic. My favorite way of playing with rigid bodies is by directly modifying the velocity parameter. The cube will always move in the direction given by the vector we assign to it, at a steady rate independent from frame rate. As mentioned before, add force allows you to push an object in a certain direction. The push given considers the rigid body's mass, velocity, and drag features to apply a calculated vector to the velocity parameter we've seen before. We set it to start or awake in order to not constantly keep adding force to the object at every frame update. Instead, we add the force only once, as soon as we click play. This is what happens when we move the method to update. If we're running at 60 frames per second, we're basically adding some push to the cube 60 times per second, making it slingshot away. And that's it for this video. Remember to leave a comment down below if you have any questions. And if you've enjoyed this video, please leave a like, subscribe, and follow for more.